Okay, welcome to the world of chemistry. In this video, we'll be talking about the topics in Chapter 5, a molecular view of elements and compounds. First of all, we know that all pure substances are either elements or compounds. And the classification of elements and compounds is shown in this figure. What you might want to know is the elements are of two types. They're either atomic, in which they're just single atoms of that element, or they're molecular, which they may be a combination of two or more atoms of the same element. And compounds then also are of two types. They are molecular, and that is they are individual molecules, or they're ionic, which charged particles are conglomerated together into an array. So study that table, and that'll give you a view of the molecular aspects of elements and compounds. An element is represented by a symbol. And it's most important that you understand these symbols are usually two letters. The first letter is uppercase or capital, and the second letter is lowercase or small, uncapitalized. It's important you realize that because capital C, capital O stands for carbon monoxide, whereas capital C, small o stands for an element called cobalt. Let's take a look at a periodic chart that has all of the lists of elements. First of all, you'll notice that the elements and names are unique. I have in this particular slide showing you some elements that are interesting. For instance, here's the element iron. It's iron, but the symbol is Fe from the Latin ferrum, and the location of iron on the periodic chart is shown there. Another one that's familiar is gold, and it has a strange symbol, capital AU, after the Latin aurum, and its location on the periodic chart is shown here. Okay? As well as aluminum, which of course the symbol is a little bit more understandable. It's a metal, and it's capital AL located here, and carbon is a single capital letter C located there, and sulfur again is a single letter capital S. It's interesting that sometimes the elements have older elements have only one capital letter illustrating them. Other times they are named after their Latin name, other times named after their discoverer. For instance, you have seaborgium after Glenn Seaborg, who discovered that element, or after a place where they were discovered. So it's important to know that there are really about 109 elements, and that seems like a whole lot of them. Actually, 90 of them are naturally occurring, and only about 40 of them are common elements. Your job in this course is to know the names and symbols of the 40 common elements. For that purpose, I would like to spend a little bit of time pronouncing them and showing you the table. One of the reasons that I want to do this video is because you could study the names and symbols, but you might really mess up on the pronunciation of them. So I'm going to start with those 40, and you'll see them then here, the name and the symbol. And the pronunciation is important because it helps with the spelling of the word. So the first one is aluminum, and you notice it's aluminum. That helps you get the A-L-U-M-I-N-U-M, and it's capital A, small l. Next one is argon, A-R. Barium. It might be helpful for you to locate these on the periodic chart. I'm just pronouncing them from the table. Beryllium and boron, bromine, calcium, carbon, chlorine, chromium, cobalt, copper, fluorine, That's one that you have to keep in mind, that it's F-L-U-R, so you say fluorine. If you say fluorine, you'll probably misspell it. Fluorine, gold, helium, hydrogen, iodine, iron, lead, and it's interesting that lead has a symbol Pb. One thing that could help you understand that is that a plumber used lead, and plumbus is the Latin, so plumber, Pb, lead pipes. We hope we don't have too many of those in our home. Lithium, magnesium, manganese, if you say it correctly, you'll spell it correctly, and mercury. Mercury has the symbol Hg, which is different from the word itself. Neon, nickel, nitrogen, oxygen, phosphorus, platinum, a rare metal, plutonium, potassium has the symbol of K from the Latin, radium, radon, silicon, silver, sodium, sulfur, tin, uranium, and zinc. So that's the list of the 40 common elements that you need to know the names and symbols and spelling of. So you can practice this. I'll provide for you these tables that you can actually, if you print them and fold them in half, you could practice with a sheet of paper, write in the symbols when you see the name, or vice versa, write in the name when you see the symbol. And not really very much effort. You really need to know the names and symbols of the elements. The next observation I'd like for you to make about the elements is that most of the elements are metals. And I'm showing you a colored periodic chart just to indicate to you some general regions on the periodic chart. One of the regions you should notice is this line here, kind of a stair-step line. It separates the metals, which are all on the left-hand side, from the non-metals, which are all on the right hand of that. In the upper right-hand corner are the non-metals, and the rest of the elements are metals. These in purple, they are the transition metals, and these below are the inner transition metals. So it's important for you to be able to recognize what's a metal and what's a non-metal by the location in the periodic chart. The second item I'd like for you to notice would be about the elements. Most of the elements are atomic elements. That is, consist mainly of one atom, but some are molecular. And the molecular elements are found on a table on page 124. They are basically the diatomic elements, two things together, and they basically are the gases: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and are basically. So you need to know which elements are molecular elements, and their symbols are written as O2, Cl2, H2, and they have to have the subscript 2 on them. So that's found in a table. So now, looking at in general about the elements, and that you have to know about 40 of them, the next thing that we're going to consider is compounds. And we have two types of compounds. The two types of compounds are the combinations of atoms into a definite proportion. One type is molecular compounds, and molecular compounds are a combination of non-metals. So you see how important it was to recognize what are the non-metals. There'll be things like carbon and oxygen forming carbon dioxide, or sulfur and oxygen forming sulfur dioxide. These are molecular compounds. The second kind of compound is called an ionic compound. And an ionic compound is always going to be a combination of a metal with a nonmetal. The metal will form a positive ion, a cation is a positive ion, and a nonmetal will form a negative ion, which is an anion. Or it might be a metal ion with a polyatomic anion group. So let's look at basically some kinds of ionic compounds. One of the examples of them, I want to first of all show you how to write the formulas. So the formulas of the ionic compounds can be best done by recognizing, first of all, in a compound, the positive charges have to be balanced by the negative charges. So we look at a substance like sodium, and we take a sodium ion, which is charged a +1, and this is the way you write it, sodium +1, and we try to combine it with a chlorine, and the ion of chlorine is called chloride ion. So sodium, and we put them together, we see that it fits like this. That's the formula for the compound. One positive with one negative, it's neutral. So this is the ionic compound sodium chloride, written the formula. Well, what if we decide to try to combine, say, magnesium, which is a +2, with chlorine? The ion is a -1. You see, I have a kind of a basic problem here. I've got to somehow or other take 2 of the negative ions to combine with the positive. So basically, I put it together, and I'm going to show this, but in the final compound, you shouldn't show any charges. But generally what happens, I'm going to have to take 2 of those and 1 of those. And so the formula for this is MgCl2. That's magnesium chloride. So I'll do another one of those to help you give an example. In general, one can get the balance of the charges if you put the charge as a subscript. Cross it over like that. Let me try combining the aluminum ion, which is +3, with the oxide ion, which is -2. Now, if you want, like mathematics, you can see that, well, I've got to have 2 of those to get a +6 and 3 of those to get a -6, and then it will be neutral. However, if we use our little transfer method, we know that a subscript 2 will go there and a subscript 3 will go there, and we'll write the formula for aluminum oxide is Al2O3. Now, it is somewhat important, though, that you realize that you would write these subscripts in the most reduced number. For instance, if I were going to do lead oxide, and I were to combine Pb +2 with O -2, I don't write this, because this is really 1-to-1 ratio. +2 is neutralized with -2. So in the writing of a formula, if you have the charge of the ion, you can easily write the formula of a compound. So ionic compounds, we know how to write the formulas. Now we need to work on naming ionic compounds. How do we name them? And naming is very important, because when you talk about a compound over the phone or in a discussion, you have to give the name of the compound. So the rules for naming the compound can be shown in figure 513. It's basically a classification. If you can class it right and give it a name, you could do this. So ionic compounds is going to have a metal, And there'll be two types of metal, type 1 and type 2. And if it's type 1 metal, basically it always has the same charge. If it's a type 2 metal, it has a variable charge. So in the nomenclature, you're going to have to indicate this. Example of a type 1 metal would be sodium. And it's sodium plus 1. It's always a plus 1. An example of a type 2 metal would be one with a variable charge. It would be iron. And sometimes it's Fe plus 2, and sometimes it's Fe plus 3. So in the nomenclature, you've got to indicate which iron. So in the case of compound type 1, you just simply say sodium, and then the name of the nonmetal part. In the case of iron, which is a type 2 metal, then you have to say iron, and then you put a parenthesis, no space, and then say what it is. Iron 2, Roman numeral 2, means it's the iron plus 2 that we're using. Iron Roman numeral 3, and it means it's a plus 3. I do hope that we know our Roman numerals. They're not too hard to do, but just a review. That's 1, 2, 3, 4, 5. You won't have to go any further than that in charges. Roman numerals. So in type 2 metals, you must say the name of the metal, and then in the parentheses put the Roman numeral that indicates its charge. In type 1, you're okay with just saying the name of the metal. And so in naming ionic compounds, we first of all decide how to name the metallic, the positive part. Now the second part is how to name the nonmetal part, the negative part. And if we're going to name the negative part, then what we have to do is to name the nonmetal and change the ending. So the first time is binary ionic. So binary means 2. And the 2 is going to be a metal plus a nonmetal. And of course, the metal could be type 1 or type 2. So let's start out with a type 1 metal. Let's say this, we want to name this compound, and we want to, we have it written. We know that this is the formula for this is a compound. This is a formula. Has a combination of aluminum and chlorine. Well, the rule is binary. So it is aluminum, which is a type 1 metal, and it was aluminum plus 3, and the chlorine was minus 1, and so that's how we got that formula, aluminum. And so how are we going to name it? Well, we say the name of the metal, aluminum, and we don't need Roman numerals because it's a type 1 metal, always plus 3 charge. And now we have to name the nonmetal, and nonmetal is chlorine, and we're going to change the ending of it from INE to IDE. So this ending, replace INE. The ending "ide" means it's binary, a metal and the nonmetal, aluminum chloride. Just one more example here. What would we name this compound? It's binary, type 1 metal, and nonmetal is sulfur. So we would say potassium, and then we have to give a name for the nonmetal part that has the ending "ide." And so it is sulf sulfide. So therefore, you have some important elements. It might be good to look at the periodic chart again, look at the nonmetals, and see how their names would change. For instance, if you're with nitrogen, it'd be nitride. With oxygen, it would be oxide. With fluorine, it'd be fluoride. Chlorine, chloride. Bromide, sulfide, iodide. So basically, those are the main nonmetals that would combine binary with a metal and have the ending "ide." Let's name one more binary compound with a type 2 metal. How would you name this compound? Well, when you look at this compound, you know that Fe stands for iron, and iron is a type 2. So what valence? Is it using +2 or +3? Well, we know from the formula that it must have been using the +3. So we name this compound iron, Roman numeral 3, chloride. There's a space there. Okay. So that's the nomenclature of binary ionic compounds. We next need to look at how to name ionic compounds with polyatomic anions. For now, it's important, I think, to have a list of polyatomic anions and their names, and they will not end in "ide." Such a list, a short list of those, is in table 5-6 of your book, and you need to really try to memorize the names of polyatomic anions and their charge. So let's just take a few of them. Nitrate is NO3, a negative charge. Sulfate is SO4 minus 2. Hydroxide is OH negative, and carbonate is CO3 minus 2, and sulfite is SO3 minus 2. So just looking at these anions, it's pretty hard to organize a nomenclature system for them. However, what we're going to have to do is use these names to be able to write a compound. First of all, let's write the formula for barium nitrate. Well, what you do is you look up barium, and you find that barium is a type 1 metal with a +2 charge, and nitrate, we look it up, and it is a NO3 with a -1 charge. Okay? So to write the formula to that, we're going to have 2 of the polyatomic anion groups nitrate. So we would write barium, and you have to keep the group together in parentheses, NO3, and then 2 of them. That's the formula for barium nitrate. How would we name a compound that we would have? For instance, we'd have that's the formula for a compound, and I would challenge you to name it. Well, you look and you name the metal, which is potassium. It's type 1, so it doesn't need any Roman numerals. And then you have to know the name of this polyatomic group, and I have it written on the board. It's sulfate. So that's one of the reasons when you're naming ionic compounds, you need to know the names, the type of the metal, and if it's a type 2, you need Roman numerals to indicate the charge. And you have to need for the cation, that's the metal cation, positive charge, and then the non-metal anion, negative charge, you have to know if it's a polyatomic and it has a name and a charge, or if it is a binary and it's just one of the non-metals that's formed an ion. Okay? So we have to be able to go both ways in nomenclature. You have to be able to name the compounds and write the formulas. We really have just one more consideration, and that's the consideration of how to name acids. So an acid basically are going to be two kinds, binary and an oxy. And these are sometimes called ternary. Binary means you have two elements present, hydrogen plus a non-metal. The hydrogen is always there in the positive place. That makes it the acid. Or over here, you have hydrogen plus a polyatomic anion. So if it's binary, then the acid always begins with the word hydro. Ic. For example, HCl, hydrochloric acid. So I said it's binary, only two elements present, and it is hydrochloric acid. Over here, it's just the polyatomic where we translate the 8 part to ic. Let me show you. An example will help clarify that. For instance, we have this compound, and you can see that's hydrogen with a polyatomic anion. And you really know that the polyatomic anion is sulfate. So we change sulfate and we call this So when there's oxygen present generally, or an oxyacid, you do not have the word hydro at the beginning. A final, easier one probably would be, can you name this acid? Well, basically, it's an oxyacid. And you know that NO3 minus is nitrate, so this is nitric acid. Let me write that down. So naming acid simply means that you're going to classify it either as a binary acid, in which you say hydro, or it's a polyatomic, which you just simply put ic onto the end of the polyatomic ion. That's the nomenclature of all of inorganic compounds and acids. And the last one is molecular compounds. Let's remember, molecular compound only contains nonmetals. Nonmetals only. So therefore, in the case of molecular compounds, we're going to be able to tell the subscripts by giving them a name. For instance, CO2. This would be carbon dioxide. So therefore, the di comes from the subscript 2. If it's the first name, we might say mono, but the first name we skip the word mono. let me give you this one. So we need to know these prefixes, and these prefixes are pretty easy. Mono is for 1, di for 2, tri is for 3, tetra is for 4. These are from the Greek. And penta is for 5, and hex. So we won't have to go much further than that. So isn't this an interesting lesson? We've learned the Roman numerals, we learned the Greek prefixes, and so this probably emphasizes the fact that chemistry is a language, and naming compounds and writing their formulas is an essential part of the language that you have to learn. Let's look at a couple more of these names because sometimes it can be confusing. These are molecular nonmetals only. For instance, let's take this. Could you name this compound? Well, yes, you could, because you basically see it's 2 nonmetals, phosphorus and oxygen. And as we look at that, then we know that it's a molecular compound, and we would just simply look at the subscripts, and we'd have to say that this was diphosphorus. Okay, so we simply have put the prefix in front of the name of the element, phosphorus, and then because it's binary, this is going to have to end in "ide," and it's going to have pent. So, we didn't say penta because we didn't want to say A and O together. So there's familiarity in practice is going to be important in how to exactly, in the end, to write these compounds. But there we've observed our rules: diphosphorus pentoxide. Okay, here's a common one, and that's carbon. Tetrachloride. So we did have to put the I to indicate binary on it. So the naming of molecular compounds is easy. For molecular compounds, it's very easy to write the formula because the name tells you. For example, I might ask you to write the formula for a compound like sulfur trioxide. This is a case where I've given you the name of molecular compound and I want the formula. It's very easy to do. You simply write sulfur, and it's understood to be only one because you don't put mono in front of the first name, O3. That's the formula for sulfur trioxide. So this in general is the kind of gist of this chapter, and I wanted to practice and give you some examples of that. My high recommendation is that you use the nomenclature summary chart, which leads you through classifying the compounds. When you have a compound, it's going to help you name it. You're going to decide if it's ionic, molecular, or an acid. Those are the 3 classes we talked about. You're going to decide if the metal is type 1 or type 2. Type 1, you don't need the Roman numerals. Type 2, you do. And then when you get to the nonmetal, you're going to decide if it's a binary, in which the ending will be "ide," or if it's a polyatomic anion. So it'll be 8 or "ide," or from the table. You can use the table to do this. Or if it's acid, you'll have to decide if it's binary or ternary. So it's a good thing to use this flow diagram. It'll lead you on the right path to give the right name and the right formula for the compounds in the nomenclature in this chapter. I also probably will be putting a link up there for you to listen to the song by Tom Lehrer. He sings a song about the elements, and after you hear him sing that song about elements, you'll be glad that you only have to know 40 elements and their symbols. So thank you. See you in the next module.